post-quantum cryptography. Quantum computers are very powerful, unlike our traditional computers, which is zeros and ones. These quantum computers, they use qubits, which can store all the values between 0 and 1. So what is post-quantum cryptography? So in post-quantum cryptography, we are trying to develop an algorithm or a system uh, so that we defend against quantum computer attacks. Since the quantum computers are very powerful, means algorithms that like RSA that heavily depend on the complexity of factorization can easily be broken. So with these quantum computers, they can easily decipher our cipher without the key. So we are trying to develop a cryptography for our traditional computers so that when the quantum computers come and they try to attack our traditional computers, our traditional computers will be safe and will be secure. So as I said earlier on, the RSA, it depends on the difficulty of factorization. So it can be broken by these quantum computers. So there are for now there are five types of cryptographic algorithms, which are lattice-based, code-based, multivariate, hash-based, and the cyc. So the lattice-based, the problem with this lattice-based is that it still requires more analysis, even though it is becoming more like the favorite algorithm to be used, but it still requires more analysis. Uh, yeah. So there's the code based. It can use a 64 by 72, and this can create a very large key, which can be used to cipher our text. So they use error coding, like copper codes, which basically assumes that there's a linear relationship. So for an error, it can for a 1-bit error in a 72-bit memory, it can easily it can easily pick up the error and continue. So it is I'm confident was it started a while ago. There's the multivariate polynomial cryptography. So this one depends on the complexity of the polynomial. If the polynomial is very simple, then it can easily be broken. Now there's the hash based, which just says for every encryption, they produce a unique cipher, and for that particular cipher, you cannot reverse engineer and come up with the key and the message. So there's also the cyc, which just stands for super singular isogenic key encapsulation. This one is the most secure for now, uh, but the problem is that it takes a lot of cycles, and it's worse than its competitors when it comes to speed performance. Then in one scenario, the worry was how much energy will these post-quantum computers need, post-quantum cryptography need. So in one instance, they used the post-quantum power sandwich. So basically, they were trying to measure the amount of power that is required by these algorithms. So they discovered that the lattice-based are the best suitable for mobile for mobile for mobile for mobile applications. So there's the Falcon, which performed really well, as you can see from the diagram. So the issues these algorithms might not work as we want according to our mathematical algorithms. There are so many variables that are there in the real life, so they might not be as efficient as we need them to be. So these are my references. Uh, Thank you very much, and it's time for contribution.